Alright, hello class. So in this video we're just going to talk about the coordinates of the unit circle and the patterns that exist with them. So yeah, let's look first over here where we have this little red line thing, right? So the question is, what are the coordinates here? We want to figure out xy coordinates so that we're able to understand certain things with the unit circle. Well, we can do this, just create a rectangle. I mean, a triangle, sorry. Why did I say rectangle? A right triangle here. And then figure out the lengths of the blues, right? Because a coordinate just tells you how much you go left or right, in other words, x coordinate, and how much you go up and down, in other words, y coordinate. And this is all relative to the origin. How much do you move away from the origin, basically, left or right, and then up or down? That's what x and y tells you. So let's look at what this is. This is pi over 6 radians, right? So that means the angle over here is pi over 6 radians, otherwise known as 30 degrees. Alright, so why is that relevant? Well, if we go down here and look at this, this is a 30, 60, 90 triangle. You're familiar with this, you've seen this before. So the interesting thing about them is proportionality. So the side across from 30 degrees is always some length. We don't care what it is, it's a length. This is called the reference length because everything else is related directly to this. The side that is across from 60 degrees is L times the square root of 3. And the hypotenuse is always twice that length in a 30, 60, 90 triangle. That makes things interesting for us because we actually already know one of the lengths here. We know this red length. This is the unit circle, which means that it has radius 1. The red length, notice, is actually a radius. So the red length equals 1. So if this is 1, then what is the one across from 30 degrees? In other words, what is the reference length? Well, let's just do the math here. If 2L equals 1, then what is L? You can fairly simply figure out that it's 1/2. So I'm just going to write that up here. So we see over here the length is going to be 1/2. And this is going up and down, right? In other words, which coordinate? It is the y coordinate. Well, how about this then? This length is going to be 1/2 times the square root of 3. So then this equals 1/2 times square root of 3. Nobody ever writes it like this. That also isn't helpful. Everyone always writes it like this. Square root of 3 over 2. So read it that way. You can also say radical 3 over 2. They both are the same thing. Square root of 3 over 2. In other words, the coordinate here is square root of 3 over 2. Okay, so before moving on to other lengths, I want to just highlight a few quick things. Notice that if we look at the pi over 6's, we'll actually get the exact same lengths everywhere. Because like if you look down here, so just extending that triangle down, we have the exact same x coordinate. What about the y coordinate? It looks the same. Well, it also is the same. Because this angle is the same. This thing itself is 30 degrees. And then, sorry, across from it, you're going to have a reference length. Here you're going to have square root of 3 over 2. So that means the reference length has to be the exact same thing. Because this is still the side across from 60 degrees. So you get a half, and then radius still 1, so where are the coordinates here? So square root of 3 over 2 is the same, exactly the same, and then you have 1/2, but that's going to be going down, correct? So it's negative 1/2. If you also look over here, you see exact same heights. You can easily compare how much going up and down that is. So over at 5 pi over 6, exact same thing going up and down, so it's going to be 1/2. And then going down at 7 pi over 6, same exact thing as over here, where we have negative a half, so that'll also be negative 1/2. And then the length going this way, so the part on the x-axis is, again, still going to be the exact same thing. It's just going the opposite way, so it's negative 3 over square root of 3 over 2. Negative square root of 3 over 2. And this should make perfect sense in terms of where the negative signs are going. Because over here, this is the first quadrant. Everything is positive there. This is the second quadrant. We have negative x values and positive y values. And so on with all the quadrants. Alright, well, let's use this then and figure out the rest of them. So I'm just going to erase these little parts here. And then we can have a bit cleaner of a picture to work with. Okay. So how about at the pi over 4s? So surprise, surprise, they're all going to be the same length and width and all that. All the coordinates are going to be the same. It's just with negatives and positives, that's going to be the only difference. So at the pi over 4s, if we draw a reference triangle here like this, then again, hypotenuse is 1. Now let's check this out. So the length across from either of the 45 degrees is going to be the reference length. And then the hypotenuse is just going to be that length times the square root of 2. In this case, our hypotenuse is 1. So the reference length is 1 divided by the square root of 2. And yes, you can leave it that way. You don't have to rationalize it. I'm not sure why that's taught ever, but apparently it is. But yeah, so you have 1 over the square root of 2, comma 1 over the square root of 2. And now you're easily able to get the other coordinates at the pi over 4s, because they're the same things, it's just with different negatives and positives. So 1 over square root of 2, 1 over square root of 2, and then the x is negative here. 1 over square root of 2, 1 over square root of 2, both are negative here. 1 over square root of 2, 1 over square root of 2, and only the y is negative here. Alright, so given that then, we have almost all of them. Now we're only missing the pi over 3s. And notice I already got the compass corners, the pi's and the pi over 2s, because they're easy. They're literally on the axis, so you can figure that out. Alright, pi over 3s. Let's look at those. So the pi over 3s, we have this reference triangle. And the thing about that is, notice it's almost the same as the other one. It's just this is 60 degrees and this is 30 degrees. So that means the side across from 30 is the reference length again. And if the hypotenuse is still 1, the reference length has to also be 1/2 still. And then the side across from 60, again, same thing, square root of 3 over 2, because the hypotenuse is still the same. It's not just going to magically change, because logic. Like, if you think about it logically, it doesn't make sense for it to change at all. So, the only change that happens here is just the x and the y get switched, because in terms of the triangle, that visually happened. The x and the y switched. The height and the length, base, whatever you want to call it, switched. So, you're going to have these coordinates at all the pi over 3s. It's just you're going to change the negatives and positives depending on which quadrant you are in. Alright, so I'm just going to adjust for those. And there you go. You got a full unit circle. You can pause the video if you want. Copy it down. It's not too difficult to derive. So if you just follow these patterns, notice that there are patterns, then things get really, really easy. If you don't notice the patterns, or if you're trying to do it in a different way, trying to memorize it, memorizing it is really hard actually. Because there's so many things to remember and so many orders to remember. But if you understand the patterns, that helps you remember things a lot more easily. So, with that said, that'll be the end of this video. We'll get into more of how to use this later on in a future video.